Hello and welcome all. So today we will be solving another one problem from the TIFR paper. So it's a problem that suggests us to use some of the conceptual things that we have learned throughout this uh, throughout your bachelor's level course and to apply it in its own way. So as you can see, the question is this. Okay, so it's a true false question. So X is a metric space such that every continuous function f from x to r is uniformly continuous, then X is compact. Is it true or false? Okay. So now fact is you need to kind of understand the concept of metric spaces, because no matter what your X is, what you choose as your metric is something that's very important in this question. So one of the properties that we have, you can also prove it yourself as well, is this, that let X be any non-empty set, then a discrete metric D is defined like this. D of x is equals to 0, D of xy is equals to 1. So y is not equals to x. So this is the way D of any x prime is defined. So if x prime is equals to x, so let's just write it like this, since I'm using y. So since D of xy is equals to 0 when y is equals to x, and 1 when y is not equals to x. Now, why do we need this? So this is something that is interesting, that whenever we have a space, let's say, let's take x to be and x comma d. So this d here, I'm specifically taking it to be the discrete metric, comma d to be discrete metric space. Okay, so then if you take any other metric space, let's say y comma d prime, and you take f from x comma d to y comma d prime, so this is any other metric space. So then f is continuous implies f is uniformly continuous. Okay, so this is one of the properties of discrete metric spaces. All right, so how can you actually prove it? So what is the epsilon delta definition of uniform continuity? That for, I will write it in short, for every epsilon greater than 0, there exists a delta greater than 0, such that for all x comma y, if x comma y is less than delta, then d of f of x comma f of y will be less than epsilon d prime. Okay, so that's how. So this is the definition of uniform continuity. This is the definition of uniform continuity, right? So now, if you look at it, that if you take D as this discrete metric space and you take your delta to be half, then D of x to y, this is practically 0. Okay, because if it is less than half, then it has to be 0 because of the choice of my discrete metric. So this particularly implies that x is equals to y. So the moment you have x is equals to y, then of course f of x has to be equals to f of y, because this is the way the matrix, this is the way that matrix spaces are defined, and this is the way the function is defined if you look very carefully. All right. So in this regard, you can always say that, of course, d prime of f of x comma f of y is of course less than epsilon, because precisely f of x is equals to f of y. This is something that we have from choosing the discrete matrix. Now let us come to our problem. So what happens in our problem is something like this, that I will take my x to be any infinite set, and I will choose my b to be the discrete matrix. So then from x comma d to r, any continuous function f, so f continuous implies uniform continuity. Okay, so any continuous functions becomes uniform continuous. Remark, let me put it down here like this, that x comma d to y comma d prime, if so, if d is a discrete matrix, then if continuous implies if is uniformly continuous. All right, the proof is written here by taking delta to be equals to half. So the moment you have this, you can take delta to be equal delta anything less than 1. You can take delta anything less than 1. It will work. Half is just something that looks familiar. So thus what we will do is that I will take any infinite cardinality set, and I will put the discrete matrix. So from there to R, now every continuous function becomes uniformly continuous. So since every continuous function becomes uniformly continuous, and under discrete metric, an infinite set can never be compact. So this is, let's say, 1, this is 2. So under discrete metric, no infinite space is compact. So hence, choosing any infinite set with discrete metric serves as a counterexample to this problem. Okay, so thus this will be false. Because I have constructed a matrix, space which is not compact, where we have every continuous function as uniformly continuous. Okay, so that's it for today. Thank you for joining. We will meet again next time. Yes, so Pratiksha, there are some videos on the ISI paper on BStat is something. I think there are some papers for MStat. So there for the BMath exam, we think that we will be posting some of the videos later on. But let's see. We will look into your queries. Okay then. Thank you.